If you have ever come across this skip alive directive in Nginx and you are wondering what this is, then this is the right video for you. Hi, my name is Harith and I am a backend and DevOps engineer. Today, we are going to look at the problem that was caused by the HTTP older version, HTTP 1.0. So each request response pair typically opened and closed its own TCP connection, which means that when a website opens a connection, it usually sends multiple requests to the server to fetch multiple files or multiple resources. So in this case, when it wanted to request one file, it will open a connection, get the response and close it. And if it wanted to fetch another resource, it will again open another connection, get the response and close it. And this was a very, very huge problem with HTTP1 because it was very inefficient. Opening TCP connections involves a costly three-way handshake. So every connection had to there was a handshake between the server, between the client and the server. And they had to and a lot of things happen in the background as well. Like so many things need to be stored for the connection to open and etc. etc. So to solve that, HTTP introduced persistent connections. So this is the one that's commonly called keep alive. And this is the one that you'll find in many server directives like Nginx, for example. With HTTP 1.1, connections are persistent by default, which means they are not closed unless or otherwise explicitly specified to be closed by the server itself. That means the client opens a connection and it sends a request. The server sends the response, but the connection is not closed. The connection remains open. And the client can then send another request over the same TCP connection after the previous one completes. So they're sent in sequence, one after the other. So after the first one completes, the client will send another request and receive a response, and then a third request, receive a response, and then a fourth request, likewise, until and uh, until and finally it has received all the data it needs to load the web page. So here we see the example. The connection A is opened up. The client requests index.html, receives a response. The client again requests style.css, receive a response. The client then requests script.js, receives a response, and then it also requests logo.png. And all of this happens over the same single TCP connection. Now, without this, what will happen in HTTP 1.0? The client will need to open 4 different connections. And with today's web applications growing so much bigger, like this can add up to like 10, 20, or even 50 or 100 uh, request response cycles. And creating 50 or 100 just for a single web page or web application by a single client. I mean, it's not, it, it's very, very inefficient. Like, ah, okay. So, what does keep alive do? So, the keep alive timeout, this is the how long in seconds. So, in this case, 60 seconds, an ideal connection is kept open. The server then closes the connection if no request comes in. If it's being used, then the server will just keep it open and request will keep on coming in. But for 60 seconds, if it remains idle, then it will close it down. Now, there is another one as well. We have keep alive requests. So for this one, is that it limits the number of it limits the maximum number of requests a single persistent connection can handle before being closed. So unlike the keep alive timeout, keep alive request says, okay, you have utilized 1000 requests in this case, 1000 requests. Now we need to close the connection. and you'll need to open another connection. So this prevents a single client from using the same TCP connection forever, basically. And then we also have another one, which is keep alive time. Now, unlike keep alive timeout, this one closes the connection even if it's being used. With keep alive timeout, it remains open as long as it's being used. Keep alive time closes it even if it's being used. Okay, so you specify keep alive time is 60 seconds. After every 60 seconds, the connection will be closed even if it's being used. Now, each open connection consumes system resources, and it's not what's that right word? It's not cheap, right? It's expensive. It occupies a file descriptor which is limited by the OS. It has kernel memory for buffers and state. So all the send and receive queues, retransmission buffers, and the entire state that it has in its kernel memory, and may also have a TLS session consuming crypto state. So all of this is data which is occupied in your memory, in your kernel, in your operating system. And connections are not cheap, right? So one thing that HTTP 1.1 does is that you just have a single connection, or not single, you can have multiple connections. Uh, with the Chrome, you can have up to 6 connections. A single origin can have up to 6 connections, and they can reuse 6 connections again and again. And the reason we have 6 connections is to make it more efficient to transfer the data from the client to the server, because of you remember that we need to wait for a request to complete. So because we want to make it faster, we just have 6 open connections, and then we can like do 6 simultaneous requests and get response. And this is also why when you have a connection, right? The reason that we need to close a connection after every kind of, sometime we need to close a connection is because it becomes, as time goes on, like 1,000 requests and stuff like that, it becomes kind of bloated, or data keeps on coming in, and then you know like there could be kind of issues, right? Like with your computer itself, if you keep it open, like if you don't restart or you don't shut down your computer, you will see it will get slow over time, it will get congested, things will start getting wrong, things will start crashing. And then once you restart the computer, everything is good. So the same thing with the HTTP connections. We say, okay, we limit it for how long we want to keep it open, so that to avoid any issues or packet loss or anything like that. So if you enjoyed this video, please hit the like button, subscribe, and feel free to comment what you would like to see, what you would like to me to explain to you in my next video. Until next time, see ya.